So question 2, a pretty generous 5 marks as you'll see for what we've got to do. Part A asks us to find a normal vector for this plane that is given at the start of the question. So normally to get this out, I guess the first mark is going to be for identifying we need to do the cross product of two vectors in the plane. And of course in this form we know that these two, 3, 0, 1 and 1, negative 1, 2, are two vectors that lie in the plane. So we're already probably up to 2 marks for writing down this little section here, and then I'm guessing the last mark is for actually carrying out the arithmetic. Off the formula sheet here is a reminder of how it works. Maybe I could just show you how I would do this one. So here I go. What I do is basically blank out the first line and treat this as a matrix from year 11 and work out the determinant. So that's going to be 0 minus 1, which is 0 plus 1, which is 1. And then erase that line and move on and erase the second line here. And then do exactly the same, but remember that this one is going to need a negative sign once we've done it. So we've got 6 minus 1 is 5, but it'll be negative 5. And then for the last one, exactly the same on the bottom line. So I kind of cover up that with a pencil, and now we've got negative 3 take nothing is negative 3. So that's the first, let me erase that out of the way, and then come back to what we're doing. So that was the first 3 marks. And then part B asks us for the Cartesian equation of the plane. So we know off the formula sheet here, A, B and C are simply the coefficients from our normal vector, and D is the dot product of the normal vector with a point in the plane. So coming back up to the question, we know that this point 0, 0, 4 is a point in the plane. So for the last 2 we get, and as this is what I mean by pretty generous, we just dot product our normal vector with 0, 0, 4, which is negative 12, and then write it down. X minus 5y minus 3z is negative 12.